Alright, so integration. So the basic way of doing would be something like that. Okay, so earlier when we do differentiation, it is always that index less 1. So now what we want to do is the index add 1, so it's just an opposite, and then divided by the result of that index, and then you add a constant, right? So this is how the basic integration works. For example, if it is integration of x squared dx, it just becomes x to the power 2 plus 1 over 2 plus 1. That gives you 1/3 x to the power 3 plus c. Okay, so if you have, like, let's say 4x to the power 5 dx. Now basically that number 4, because it is a constant, it has nothing to do with integration. So you kind of like leave it out. So it's like 4 multiplied by, and then you are integrating x to the power 5. So x to the power 5 at 1 over 5 at 1. And then that gives you 4 over 6, x to the power 6. And then you must always simplify. Your answer must be simplest possible. So 2 over 3, x to the power 6 plus c. Okay? We okay so far? Yes. You can add c only at the last step, only at the very last line after you've done everything. That is fine. And this is the only thing in add math that you can suddenly add a c at the very last line. Okay? Right? Okay. So I'll give you an example. For example, let's say, okay, this is exercise 15.3, question 3. Okay, you were told that the dy dx of a curve is 10x to the power 3 over 2, and then minus 2 over third x. Okay, and then it says this curve passes through this point. Okay, and then you're supposed to find equation of the curve. Now, what is the meaning of finding equation of the curve? What does this mean? So what is equation of the curve? That means you are supposed to find, what are you supposed to find? Find y, eh? Okay, remember the curve is always y equal x cubed or x squared plus blah blah blah. Okay, yes. You get the gradient, yes. If you sub x inside that divided x, you get gradient at that point, 0, 7. But gradient only at that point. And this is equation of the curve. So it doesn't work that way. Okay? Alright? So that, if you're asked to find the equation of the tangent, yes, that will be done. Okay? But this is not, because you are asked to find the equation of the curve. So the equation of the curve will be y. So how do you find y then? So you need to integrate the dy dx. Okay? So y, okay, your solution would be y equals to the integrate of dy dx with respect to x. Okay? So this is how it is set. Integrate dy dx with respect to x. So that integration and the dx is like a symbol. So it's always there. Alright, so you are going to integrate 10 x to the power of 3 over 2 minus 2 over square root of x, and then dx. Alright, so how do you integrate this? Again, 10x, you just have 3 over 2 plus 1, and then you divide that whole thing by 3 over 2 plus 1. And remember, because it is plus minus, you integrate individually. Okay, yes, coming. Okay, so this thing, How do you rewrite this in index form? It would be 2x to the power. Okay, negative half, huh? Yes. Yeah, it's sort of like you're not integrating the 10 because the 10 has nothing to do with integration. So you just leave that 10 outside. That means you're not doing anything to the 10. Yeah, we're not doing it. I'm just writing it there, and then we're gonna work the rest. Okay. So here minus 2 and then x. It was a half there. It was this number there. So what do you want to do? You add 1 to that, right? So it becomes a half, and then the whole thing over half. Okay, Ken? Okay, then the next line we will have 10x to the power 3 over 2 plus 1 will be 5 over 2, yeah? And then you're going to divide by that same thing, right? So it's, and then you multiply by 2 over 5, yes? Yeah. Okay, and then minus. So what happened here? Yeah. So the first one is also a 4, right? Because you cancel that out. So it's 4x to the power 5 over 2 minus 4x to the power half. So this is your y. So you finish integrating. Now, do remember, what are we missing in this equation? No. What are we missing? The c, okay? Plus c, okay? Now, then go back to the question and say, what does this mean? It passes through the point 0.7. This is where you need. When x is 0, y is 7. Okay? So then now you substitute 7 equals 4 times 0. Now you can choose to write power, whatever. It actually doesn't really matter. So therefore, c is 7. So what is the equation? Y equal 4x to the power 5 over 2 minus 4x to the power half plus 7. Yeah, you just leave it like that because now if you look at this line here, x to the power 5 over 2 and x to the power half, what is the best you can write? Probably just the second one. Instead of writing x to the power half, what do you write? 4 square root x, right? Does that really do anything? I mean, does it actually look any simpler? No, it doesn't. Can you make it any simpler? No way. So, like I said, your y, whatever your final answer, is always, as long as you find that it is simpler. The simpler means if it is 2 terms, you write it as 1, that's called simpler. If you can write it as a factorized form. Again, there are 3 terms here. Unless you can factorize all 3, right? Then it is simpler. If you only factorize the first 2 and the third one is still there, it's not any simpler. It is still 2 terms or 3 terms or whatever it is. So no use, okay? So no need. So this is it. This is the final for this particular one. Yes. Is there any questions so far? Yes.
Can you repeat again the first step and the previous step? Like how do you simplify?
Like here? Okay. So what you're doing here is like this, right? So you add this. This becomes 5 over 2. That's what this is. Okay? And then you also divide by 5 over 2. Because you are dividing, so it's like you multiply and then you switch the numerator and denominator. Okay? So you switch numerator and denominator. Alright? And then you multiply by 10. See, this is what I meant, like the 10 is not in any part in the integration. So you're not doing anything, you just leave it there. You finish everything else, then only you do that. Because that's just a number, right? So it's quite simple to do that. So it's 10 multiplied by 2 over 5. So if we can cancel this out, so that gives you a 4 here. Okay? 10? Alright? Okay, so this is what we do with the integration and how we use it. Okay, earlier you given y, you do a dy dx to find the gradient. Now you given dy dx, which is the gradient, and you're going to work backwards to find the equation of the curve, which is y. Okay, that's one of the objective of integration. Okay, Ken? So far so good? Okay, we move on to the second part, yeah? Now the second part that we're doing would be integrate something like this. Let's say if you have 2x plus 1 to the power 3 dx. Now again, to the power 3 looks okay actually, even if you are going to expand it, right? But then again, sometimes it can really get very, very bulky. So what do we do here? Now this is a bit simpler like what we did in differentiation, that bracket thing, right? So you are assuming that this entire thing is a bracket of x. Okay? So what do? You're gonna, when you integrate, so it just becomes 2x plus 1. Now this part was exactly the same as what we have done earlier. Now what is the extra thing here? The extra thing would be this number here, right? So this is where you get that 2 there. Okay? Alright, so that 2 is the result of the dy dx of 2x plus 1. Okay? So this is what it means. Alright? So again here, 3 plus 1 is a 4. Times 2 is 8. So 1 over 8. 2x plus 1 to the power of 4 again, plus c. Okay? Right? Okay? So this is how we go. Again, if you're not so sure, you have a little bit of doubt, you do a differentiation. How do you do differentiation? Bring this down, right? And then you differentiate what is inside here, bring the 2 down outside, right? So 4 times 2, you cancel out that 8, right? Yeah? So which gives you this one. Okay? Right? So this is like working backwards. Right? So one of the things about integration is this. Once you integrate it, something, if you're not so sure, something that ticked you off. So what do? You differentiate your answer. When you differentiate your answer, it should give you back your question. If you don't get that question, something is wrong somewhere. Okay, so this is a good way maybe for you to check your answer for integration. Okay, right? So otherwise everything else is the same. So if it passes through a point, for example, then you substitute x and y to get c. To confirm that c. Otherwise, you just leave the c there. Okay, Ken? One more thing. Now, you would only get the most complicated on this type would be just this, like for example like this. Okay? Now what I'm trying to say here is this. You wouldn't get like an x square here. No. Inside the bracket is no. It's always just that x. So this is what you do. Okay? It wouldn't be anything more complicated than this. So it is just like this. So how do you integrate this? So 5x plus 7. Remember, you take this whole thing as 1x. And then just 8 plus 1 divided by 8 plus 1. And then you multiply by 5, which is that first number there. Yeah. Okay? Which is that first number. Okay? So 8 plus 1 is 9 times 5, so that becomes 45. And then 5x plus 7 to the power 9 plus c. And that's it. That's all you have.
So the first constant you can get.
Yeah, that constant, any number, but the x is always just to the power of 1. Okay, so that's it. That's all you have. So it wouldn't be anything more complicated at this stage. Okay? Alright? Let's proceed 2 more parts. Okay, we do everything. I'm putting this on recording, and then we'll just send to you. Yeah, so you can. Yeah, you. Where do you want to put? Huh? You want to put on YouTube? Okay, let's try this. So what is this equal? Just that lah. And remember, when you differentiate E, you get E, right? So integrate E, also you get E lah. Same, right? The only thing extra is that constant. No chain rule, no product rule in integration. Okay, so that is not in the syllabus. If you proceed in that level, yes, you're required to do all that.
Until natural.
Huh? That chain rule. No. You have sine, cosine. Yeah, that's right.
Then got double derivation.
No double derivation, no product rule, no cosine rule. No product rule, no quotient rule. Okay, so just this.
Is it possible to double integrate?
It is. Okay? Right. So more complicated would be, let's say, 3x dx. So what would this be? So remember, you differentiate E, you get E. You integrate E, you also get E. It's not a 3 down, but it is 1/3. Okay? Again, you're not sure, right? You differentiate your answer. You differentiate E to the power 3x, you get E to the power 3x times 3, right? That's why you divide by 3 lah. Yeah? See, if you differentiate this, you get this, right? That's why this 1/3, it's here. So that cancels off because this one has 1. Alright? Okay? Okay? So the answer becomes just this. Okay? Alright? So again, if it is just adding, so if you integrate, let's say e to the power 2x, let's say plus 3e to the power 5x, for example, you just integrate individually. So this become half. Okay, remember? So it's just e to the power 2x, and then you divide by, that differentiation, right? Okay, and then plus e to the power 5x, and then over 5, right? So the 3 remain because it is a constant, right? So that's it. Okay, everything else is the same. If you are required to find C, you need to know it goes through one point. That means when x equal to something, y must equal something. That you have to know to substitute so that you can find the C. Okay? Right? So this part is integrating exponential function. Okay? You think we can just do one more? Okay. Would be integrating trigo function. There is a manipulation. Okay, or maybe we do that. Oh no, we can do this. Okay. So how do you work this out? Integrate cosine x dx. What would it become? It's just sine x plus c. Okay, so integrate sine x dx is negative cosine x. Okay, remember when you differentiate cosine, you get negative. Yeah? Okay, again, integrate cosine 2x dx. What would it be? It would be sine 2x and then half. And if it is integrating sine, let's say 5x dx, it would be negative cosine 5x, and then this time is 1 over 5 plus c. Okay?
5 sine x.
Alright. How about 5 sine x dx? Again, the 5 has nothing to do with that. You are only integrating sine. So when you integrate sine, what do you get? You get negative cosine x, right? And then the 5 just remain. And we're done. Okay? Right? So you're not doing square. Okay? Integrate sine square. No. Not doing that. Alright? So that's it. So it's only a multiple angles. Okay? Like for example, integrate, let's say sine 2x plus pi. How do you integrate this? So remember, it is a sine function. So you integrate a sine function, you get a cosine function. And everything must follow that, whatever in the bracket, right? So after that, what happened? Because it is 2x, right? So it becomes, sorry, it's a negative, huh? So it's a half. Alright? You integrate the sine, you get negative cosine, right? And then you got a half, and then a plus c, and we're done. Pi is a constant. Okay? Okay? Alright? Okay, we will stop here on this part. Okay? For now. Alright?